All right, we're back with part two. Example two. Fredette wants to have $600,000 saved for her retirement. Good plan. If she's now 23 years old, what weekly investment should she make at 4% compounded weekly, small interest rate? She could probably do better than that if she had a decent investment, but we're going to say 4% compounded weekly so she can retire when she is 62 years old. Again, use both the formula and the calculator. So again, we know we're going to use one of the formulas that we developed today that has R equals, right? R equals whatever, the weekly investment. But the question is, this is just a little picture of the time frame, right? There's now, there's the end, right? And we know which formula is depending on where this 600,000 bucks goes. This 600,000 bucks, here's all of her payments. She's saving up, right now she's 23. And this is going to be when she's 62, and there's all these years of weekly payments. Where's the 600? Well, it's going to be at the end of her career, right? She wants that $600,000 to be there for her retirement. So this must be an amount question. So if I look back in the formula, there's the formula rearranged for the regular payment. Now, could you use the other formula? Could you use this formula? And just substitute everything in here, like substitute all this stuff into here and into here, then solve for R? Yeah, and we had practice using that skill, but I think this one's easier. If we have this form like it is already, we're going to use this one over and over again today, so it's a good idea. The amount at the end was the 600,000 bucks. I was 4% compounded weekly. Now, notice that's a nasty number. We're going to leave it just like that and put that into our calculator like that because it's too nasty of a number. N is what is N? Oh, we got to figure it out, don't we? Well, it's weekly, but we got to figure out how many years. So if she's 62 when she retires, she's 23 now. We'll pretend she just had her birthday because otherwise we don't know when it is during the year. Well, we do the subtraction, and that's 39 years. That's a long career for Fredette. She's working hard for a long time there. 39 years. And that is a good long time to invest. 2,028 weeks of investment. And then now I just pound this into the calculator. Notice it's a little bit tougher when I is one of these nasty numbers, and we'll practice putting that into a calculator here in a second. And then I got bracket 1 plus 0.04 over 52 to the exponent 2028, subtract 1. And here we go, here we go. I'm going to put this into the calculator. 600,000. Watch my zeros there. 600,000 times bracket 0.04 divided by 52. 52. Look at that nasty number. And then divided by, that was the big division bar, bracket, and then the inside bracket, 1 plus 0.04 divided by 52, bracket to the exponent 2028, and then minus 1, and then end bracket equals. Does that seem reasonable? That she should make payments weekly. This every week she's going to invest $122 a week, and then it will build up to $600,000 by the time she retires. This seems reasonable. It seems like something that she could actually do. She should invest $122.88 per week. What's that going to look like on the graphing calculator? All right, well, We got how many weeks? We said 52 times 39, and the interest rate was 4%. Again, it's gonna take care of the weekly 4%. The present value, well, nothing. She's got nothing in the bank right now. The payment is what we want to find. We're going to come back and solve for that. The future value is how much she wants to have saved. And she's saving weekly, not 55 times a year, 52 times a year. And then we want to go alpha solve for the payment. I got all those values in there. That was 0. This one's okay. And then the payment is what we solve for. 88 and change. Future value is 600,000. One thing that's nice about using the graphing calculator, I suppose, is that you change stuff in it so fast. Like, what happens if Fredette wanted to be a millionaire? Right? What happens if she wanted to be a millionaire when she retired? We change that, and it's so fast. So you solve it. Well, that means if she wanted to be a millionaire, she'd have to put $200 away a week. Well, what happens if she could get 4.5% interest instead of 4% interest? What would that change? Well, she'd have to put $20 fewer a month to become a millionaire. And then, I mean, these questions, how do we what's reasonable to put in here? Could she get 9% interest? Not likely, but if she could, she's putting away $50 a month, $53 a week rather, $53 a week to end up with $1 million when she retires. See, that's pretty neat. And with the graphing calculators, we can investigate that quite quickly, and we'll do some of that before things are all said and done in this unit. What else do we got? We got one more little thing. One of the biggest things isn't using the graphing calculators. It isn't even using the scientific calculators and remembering the formulas. It's this idea of deciding whether it's an amount A question or a present value P question. Because once we can look up the formulas, that's no trouble. What's this idea of, here's the time going by, present value, payments in the middle, amount at the end. So this $15,000 wants to repay his student loan of $15,000 by making equal annual payments. Where's the $15,000? Well, that's what he owes right now. And then he makes the payments after, and then at the end he'll owe 0. So this is a present value question. When he saves $5,000 by making equal payments at her bank. Well, here's now, and she's saving up, and so where does the 5,000? Well, she doesn't have the $5,000 now. She's saving for it. This is an amount question, isn't it? Sergio plans to retire a millionaire by making equally monthly payments. There's the $1 million. This is an amount question, isn't it? Amount at the end of his savings. Veronica plans to make quarterly withdrawals from her $300,000 retirement income fund. So this one's a little bit different because right now there's the present value, and there she's got $300,000 and she's going to take out from that. So to me, if she's got a whole bunch of money and she's taking out from that, she's going to have 0 at the end after she's done taking out. So where's the $300,000 is the amount that she has now, and she's going to take out from that as she goes. So this one's a present value. Hopefully that little exercise, we would have done it together, but you just listened to me, and that's okay. You can chat about these examples with your classmates once you get to the homework. Notice there are some choices there that seem interesting to you. Try and do a fairly good variety of them. C'est tout.